I want to talk about how or what's unique about a regular hexagon. Okay, so if we're looking at a regular polygon with 6 sides, the entire process follows along the same line. Okay, you need to first find your reference triangle. Okay, so if we plot our center, sketch in one of those triangles. Okay, that allows us then to find the vertex angle of this reference triangle. Okay, so what would the vertex angle be for a regular hexagon? This angle is 360 divided by n, and so what's that going to be? 60. Okay, now what's unique about a regular hexagon is we still have an isosceles triangle, but if the vertex angle is 60 and we're dealing with an isosceles triangle, what do the two base angles have to add up to? 120, and if base angles are opposite equal sides, they're equal as well. So 120 divided by 2 is 60. So what's specific about the reference triangle in a regular hexagon? It's equilateral. So once you draw in your vertex angle for that reference triangle, you're then going to draw the apothem. Remember, this is the altitude or the height of that reference triangle. Okay, and so for this particular triangle, when we draw an altitude in an equilateral triangle, what kind of triangles do we create? 30, 60, 90s with a pattern of x, 2x, x root 3. And so if we're looking at this particular problem, if we know our whole side length was 10, when we draw the apothem, it splits this into half of 10 or 5, which means our overall height for that equilateral triangle will be 5 root 3. And so once you get all of those pieces, so SA and N, okay, you know N from the number of sides. The S or A will be given. So you can find that. You might need to use trig, and it'll usually be the tangent ratio. Okay, or you might use 30, 60, 90 as your special triangle. And then you just plug it into your formula. 1/2 SAN. And so in this particular case, our side length was 10, the apothem was 5 root 3, the number of sides was 6 because it's a hexagon, and so you can just multiply this through. And now, let's take a look at this. If I asked you just to leave your answer in terms of the rational form, or in the radical form, so the exact answer, not an approximation. Hey, can you guys multiply this out? Leaving root 3 in your answer, but can you do that relatively easily? 1/2 times 10 times 5 times 6. Yeah, you don't have to multiply left to right. Okay. Right, you don't have to say 1/2 of 10 is 5, 5 times 5 is 25, what's 25 times 6? Okay. Again, you can still get it, but if you were to reorder this, what is half of 6? Half of 6 is 3. 3 times 5 is 15 times 10 is 150. Root 3, the units are unknown, so we can use u squared because it's a two-dimensional measurement. Okay. All right, does everybody see that the regular hexagon is a special case? This does not work with all regular polygons. It only works with a regular hexagon that allows you to create the 30, 60, 90, because a number of students sometimes when they're working with just random right triangles, they often want to put the properties of 30, 60, 90 in there. This can only work with a regular hexagon.